That is exactly what it is. Okay, so I am recording. We're going to be covering installation, getting started, which just means like, npm run dev, getting it run locally. We'll do just a quick hello world of getting in, making sure that an actual graph runs. We will go over the project structure of the monorepo in detail, and then we'll look at the database and talk about how we're using it in dev versus prod, because we're using SQLite in dev and Postgres in prod. And we will also look at plugins, and then how you can add and remove plugins, and what the kind of plugin interface looks like. So first things first, installation. If I go to github.com/nearcom/magic. Oh, I realize I'm probably not sharing my screen. Let me do that first so you guys can see what I'm seeing. Probably helpful. Can you see my screen? Not yet. Weird. Stream failed to start. Okay. Got it. Okay. So I've made a little HackMD here. But we're going to start here with installation. Okay. So obviously I will take it and clone it. Go into VS Code, make a new tab, git clone, Magick ML. Let me do it here, and we'll say Academy Magic. Okay, that's cloning, but obviously I already have a clone of it here running. Let me just close all of my things. And from there, I'm just going to check out development, check out origin development, so that I'm all kind of reset. And if I'm in a new repo, I will obviously run npm install. And hopefully it doesn't have to do much because I've already installed. But once you've done that, you can run npm run dev. We have some stuff to check. So if you run npm run dev and your branch has changed, it's going to possibly run npm install again. This kind of is just to fix a lot of the issues that we have with the way our plugin system works when you're changing branches. So if I run npm run dev, that should actually also call my pre-install scripts, checkinstall.js. You can see it's calling a bunch of stuff to verify that everything's cool. You see how it says new revision detected. It's actually doing an install on npm run dev as well. A little bit of it's a little bit slow sometimes, but it's pretty harmless. And if you do it once on your branch, it doesn't have any time cost. So this is going to start up the monorepo, npm run dev. A bunch of things are starting up, and they take different amounts of time to start up. So while you can see that it has started up and given me the localhost link, it's still also starting up things in the background and servers and stuff. Now, another thing you'll see is it's throwing errors, like plugin email server cannot be resolved. Let me just make sure. So the reason that's happening is because the wrong default plugin, let's see, is there. That's so strange. It should not have this plugin. So we probably need to just run npm install again. It shouldn't have an email. So we'll go over the plugins in a second. They're set here, and there's no email plugin, so it shouldn't have one here. That's so strange. Oh, I know why. It's because I have a .env.local. Let me just delete this. So I can override the plugins that I'm using, and I'll cover this in a second, in a local environment sort of file, .env. So let me just clear my .env. So I don't actually need a .local. By default, we have a .env here that has some environment variable settings that should be fine for you. But I might sometimes override like the plugins, or I might override the database type to be Postgres if I'm testing Postgres locally. So by default, you shouldn't have to change anything. This should just work and be what you want. But if you're doing plugin development or something else, you might need to make it .env.local and change this. Otherwise, okay, let's just rewind a bit. Now I have kind of a blank slate. I ran npm install, I run npm run dev. It should just work. You can see it starting everything up. I'm going to go to this localhost 4200, and it's probably going to throw some errors or just not build yet because it's still building in the background everything else, including the server. So you have to wait, a minute. There we go. Now it's built. It's still building the docs in the background. You see just finished. The docs are at localhost 3001. And you can see that if you want to edit the docs and have them dynamically regenerate, you can. If you just want to see what the docs are as you're going in the current latest version, you can. You can see we can go to core concepts. We can read all about these. I highly recommend that you read through all of the docs if you haven't, especially these ones, connectors. And then the nodes have not really been completed yet. That's something we'll be working on soon. But some things like the developer guide also cover a lot of what we're talking about, like setup and package overview and how to develop plugins and all that stuff. Some of the docs might not be totally up to date. If you see anything that's not up to date, please update it. It's worth taking the time. We also have some auto-generated API documentation. So we'll be having this through all of our packages. Right now it's just in our engine package. But basically, we use something called tsdoc. And tsdoc is a TypeScript version of JSdoc, which adds this kind of comment format. And this comment format can then be generated out into our actual docs documentation. So we have GPT-4 generating a lot of this for most of our code base. Some of it is perfect. Some of it needs a little bit of work or explanation. And we're going to, once we've played catch up, we're going to go through and kind of make sure that all of our docs are really, like everything in our code base is well documented like this. And then it can generate out to be here in our classes. So if we want to, look up specific classes or, go through, you can see this is in our Magick ML core. It'd be great if we could, go through each of our different packages and see what's in there, make it searchable, and also feed this into our agent so that we can talk to our docs. That'll be the next thing. So right now we have this, but the next thing will be some sort of agent that we can feed all of this stuff into. Cool. So docs are highly useful. We really want to emphasize this. Let's go back to the IDE. So when I join the IDE, the first thing you see is, we should probably make this could be a little cleaner, but we're throwing a warning that you need to set your API keys. In the future, we're going to wrap the API keys. You probably won't need to do this, but this is how we're doing it now. So let's say, cool, I can go to the settings and set my API key. I need my OpenAI API key to do most of the stuff that I'm going to do inside of the, the actual AI development inside of Magick. I can go get that. I'll go to platform.ai.com. I will go to view my API keys. I will delete, create a new one. Oh, cool. They have names now for keys. Magick dev key. It's so useful. Wow, I didn't copy it. Magick dev key. And copy it. And then I can go back to my OpenAI API key here, paste it in there, and that kind of warning went away. Now I can create a new, right? I'm just going to create like a hello world. Boom. Create a hello world, and there you go. Now I have kind of a basic spell. You can see I'm at localhost 4200. Everything is working. I can type in tests, and I get the exact same thing back in response. There's a console here, which will show me the data that comes in and out of every node. If I wanted to troubleshoot or debug, I can go and say, okay, well, 494, node 494 is the message from event to structure component. Cool. And I go in there, and I can see that the input was testing, and the output was also testing. Okay, cool. Interesting. Right. And then I can see there's some data that goes in, data that goes out. Here's the socket inputs. The socket outputs, etc., etc. Great. over here I have agents. We'll just go through this really quickly. Agents have connectors. Agents are running. They're basically like a running game server kind of thing. One agent usually manages all of the connectors. It needs to have active state. So like if we start up a Discord server, it needs to run somewhere. Discord bot needs running somewhere. You can add Twitter to that. You can add an update loop so it can wake up, do some stuff, maybe send out a tweet, go back to sleep, or like work on a task. This is kind of our like AGI loop thing. We also have a Blue Sky connector, and we're adding a Gmail connector here. It's what I'm working on next. And this is basically all the different socials and stuff. You go in here, you can enable it, disable it, add the API keys, whatever you need to kind of set it up. You can see there's voice enabling for Discord. And so this is kind of the other big thing is you connect the agent to a root spell. So this is where like when data comes in, it's going to interact, be parsed by that root spell. And so yeah, this stuff is all covered in detail in the Academy videos. We have events. Events are things that you can record. Use this for basically short-term memory. You can also use it as long-term memory if you store the embeddings. Embeddings are also covered in the Academy. They'll be covered mostly in the next one on Wednesday. So just to be aware, events are basically you have a sender of the event, an observer of the event, which is usually the agent, and then the sender and the observer could be the same. The agent could also be the one creating the event if the agent is saying something. But this is how we track conversation and various kinds of memory, things that happen in the world. We can have different types of events, like these are conversation events. We could also have, player events for if people join or leave or whatever, or emote events, or you can imagine all kinds of different events. We have requests. Requests are kind of like events. We're recording all of the data that's happening, but this is specific to basically models and services, things that cost money. The idea here is that we can track. You're going to have a lot of questions about how many models you're using, when you're using them, how fast they are, which ones are better than the others, which ones cost more. And requests let us derive those kinds of broad analytics, as well as look at and troubleshoot individual things we did. So if I send out a thing and said, hey, this is a test, I can see how many tokens it cost, how long it took. I could try different models, and I could see like the request time was much higher on like a Palm than a ChatGPT or something like that. No, I mean, these are all metrics that matter, right? We have cost, request time. There should be number of tokens here somewhere. If we're not showing number of tokens, then we are recording it inside of the response data. So we can parse a lot. Like you see, this is going to all be redone. We have a new design for this. But inside of here, there's a bunch of data. And in that data, there are things like how many total tokens, prompt tokens, completion tokens, and then total tokens. Some, what model we used, when it was created, how long the request took. If there's any other things that we need to add, we should, but that's kind of what we're doing now. Yeah, so those would have cost as well. You'd create your own cost calculation. If it's truly self-hosted on your own hardware, that might just be energy use, electricity, but it's gonna have some cost. So let's see. Can you guys give me 1 second? I'm getting a phone call. 1 second. Hello?
Hi, is this Shaw?
Yes.
Hi, Shaw. This is Mariana calling with 2020 Optical. How are you?
I'm doing well. How you doing?
Good. Thank you so much for asking. I'm so sorry to bother you. I was just inputting your information into the computer system, and I wanted to make sure your phone number was 4399, not 4933.
That is correct.
So you just confirmed that.
Awesome. Great.
Thank you so much. Bye-bye.
Have a good day.
You too.
Sorry, was my optometrist. Okay. Let's see. So we've gotten through requests. Now we have a few other windows. A couple of them are hidden, like the chat window is hidden because it's not finished. It's a plugin we can add. One that we do have here because we're working on it, but it's also not finished, is the avatar window. The goal here is obviously if we can talk to the avatar, they talk back. Wouldn't that be nice? There's also a microphone. Hello, test, 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 test. Maybe it works. I don't know. And then you can also drag and drop VRMs here. So this is something we're gonna push on pretty hard soon, and also integrate with the Looking Glass, so you can have like kind of a hollow character thing going on. And that's it kind of for the interface. There's a lot more. There's a lot we could cover in the. We'll cover it all in the Academy stuff. We're teaching all of our users and everybody on our team how to use this interface. What's really important is that we understand where the actual code lives. Cool. So, we covered installation, we covered getting started, we covered this. Now let's look at the project structure. Okay, so I'm going to go back to VS Code. Okay, so we have three main folders here where code lives. The first one is apps. One thing to know is that we use NX, and NX is a monorepo management tool. It's a bunch of stuff, but it's kind of grown over time. But if you type in NX monorepo, you go to nx.dev. This is what we're using. It's a build system with monorepo support. Most people are building this, with monorepos in mind. The idea of a monorepo is that all of our code lives in one, massive repo with lots of plugins, lots of packages. But it really helps to manage dependencies and have them all rely on each other without having, tons of submodules and craziness. It really helps with versioning and stuff like that as well. There's some great videos on this. I'd highly recommend watching like an entire introduction to NX workspaces, how NX works. I mean, this is a lot of our non-coding wasted hours can be attributed to not enough understanding of the NX build system. And so investing the time up front and not just winging it, but actually learning how this stuff works will save you hours and hours and hours. It's just not something you're going to know how to do unless you've done it before or have been directly trained on it. So NX, that's really critical. NX manages things in they have this sort of their own way they recommend things to be, which is that you have apps, which are very lightweight. And those apps then import packages, which is where most of your code actually goes. And then we've added this kind of convention. We used to have all of our plugins be in our packages folder, but it was quite crazy, and they really obviously represent a different kind of paradigm. So we moved all our plugins into the plugins folder, which is also a bunch of code. So apps first. We have 4 main apps. We already saw the Docs app, which is a Docusaurus based app. The other app we saw is the client. That is our front end application. On the back end, serving that is the API server is this server folder. And then running the actual agents, when we start an agent, you can see here I've got these heartbeats from Discord, all this crazy info stuff. This is the agent app. So 4 apps, right? The client is what we interact with. The docs is docs. The server is what our client contacts, and then the agent actually runs our standalone agents. In the client, you can see very little source code. We have a main.tsx, and that main TSX basically sets up the plugins, sets up our external stuff if we need to inject a token from our trusted parent URL, which is our cloud. And this kind of initializes everything and gets it all started. But pretty much all of the code is actually brought in from this editor package, which we'll get into. That's actually a package. It's not an app. This Magick IDE object is like our entire editor. And this will be on NPM, so you'll be able to install the Magick IDE into your own stuff. That's something we'll be working on soon. I mean, it's already packaged. It just needs a little bit of work to work in different environments. Yeah. We'll get into the editor package in a minute. So if you look, basically the client just imports the editor, imports some stuff from core, imports some React stuff, and sets it up and goes. The other thing the client has is Electron. We use Capacitor. Capacitor is it's by Ionic. It's basically a way to make cross-platform apps that don't have any native code in them. So our web app that I just showed you also will build to a desktop app, as well as an Android app, an iOS app, and a progressive web app. And we would like to pretty soon, in the next like 6 months, have all of those going as automatic deployments in our CI/CD, so that they get built and deployed to the stores and all that stuff automatically. And that way people can get Magick anywhere. I think that kind of saturation, you can get it on the Steam store, you can get it on the iOS store, is going to be hugely critical to our success and adoption. So we have this set up mostly. It just needs this kind of CI/CD auto build and marketplace kind of side of it done. In Capacitor builds to this Electron folder. Right now we're only supporting Electron desktop, but there will also eventually be an iOS and Android folder in here. And so this actually holds all of the code for the application to build natively. So there is also a native client coming. Is basically what I'm saying here. And that lives in this client package. In the server package, it's kind of the same thing. Oh, one other thing I want to point out. There is a plugins.ts here, and this is auto-generated based on our plugin system, and I'll get into that in a second. But there's a plugins.ts in the client, in the server. This allows us to dynamically change and load plugins, and also allows users to configure their own server with their own plugin setups. So if we do like an AWS Marketplace instance of Magick, you can be like, well, I don't need this, but I do want this plugin. I want my own custom plugin, and et cetera, et cetera. Cool. So then we have server. Server is kind of the same thing where it does, you can see it's setting up Koa, and we use Koa instead of Express, but basically Koa is a HTTP framework built from the same people who made Express using modern syntax. Koa is wrapped by Feathers.js. That's another big one we use as our framework. If you've never used Feathers, it's great. It's a full stack web framework. It does real-time streaming. All of our services are available everywhere, so we don't have to make like crazy WebSocket calls and stuff. It wraps WebSockets, it wraps HTTP, does a bunch of stuff for us, makes it super easy to make new services and like, CRUD. So if I want to make like a document service, I can just generate it. We use this heavily, and it would be really good for you to also do some tutorials in Feathers. Feathers. I think there's probably a new Feathers 5 new thing. Hopefully, we're using Feathers 5. There's a Feathers V5 intro and overview. This would be highly useful. Probably should probably post this in our chat. So yeah, we use Feathers heavily in the server, and they have a services architecture, and the services are dynamically loaded. Interesting. I don't think we're even using this one here. Yeah, we're not using this one. We're dynamically loading all of our services from our core, and then we also have plugin services. So we could probably even just get rid of that. I'll clean that up. But pretty much the server is very lightweight here. You can see it's just like initializing plugins, initializing our speech server, file server, text-to-speech. These will probably have to be redone a little bit to scale. It gets the server initializations for all of our plugins. So when the server initializes, it can also initialize all of our plugins. It sets up our database, especially for a vector database and stuff. Passes that stuff down. Sets up our error logging. Sets up Koa. Handles our Koa routes, so that we can have, aside from our services, we could also just have like straight up Koa routes if we wanted to, which would just be like, any path / API, whatever you want, and then processing those routes. And that's the entire server. There's not much here. It's pretty standard stuff. Mostly, again, the code is getting pulled from server core, which is a package, and we'll get into that in a second. There's not really much in the actual app. The agents are the same thing. Very lightweight front end. it starts the agent manager, starts the world manager, which is basically worlds are an abstraction that could be seen in 3D or 2D as like tracking the entities that are in the space with the agent, and then running the stuff within that. So I can probably get to, let's see, world manager. Class world managers here. You can see it's basically manages adding and removing users from a space. It lets you do things like get the user distance. Are they talking about the same thing they were talking about before, etc. Probably needs a bit of refactor. This is kind of some of our old stuff that needs to be reviewed, but this could be useful for creating like 3D rooms or conceptually a 3D room out of a 2D room. And the agent manager basically spins up new agents as they are detected and has them do stuff. Cool. So those are the apps. Those apps import packages. The packages are roughly core and editor, and then the core is split up into shared core stuff. This is MagicML/core. This is MagicML/client core, which is the client packages, and then MagicML/server core, which is the server only code. So the vast majority of code for MagicML is in core, right? If you look through, the client contains a lot of components. These are very basic React components that are used everywhere. This is like our React component library. It contains a couple of contexts and templates that are imported into the front. The idea here is that some of these things need to be shared by multiple packages, maybe imported into the app or imported into the editor. So this is kind of a core client dependency that everything else depends on. It has no dependencies of its own, except maybe the shared. Same thing with server. The server has a lot of stuff in it. Some of this stuff are like the services. This is where the actual Feather services are, which are backend spell handling, spell running, the event CRUD, storing and recalling events, storing and recalling projects, agents, documents. That's all happening in the services kind of thing. Servers will probably be deprecating soon, but these are like if you wanted to upload a file or handle voice or TTS, SCT, that's all handled with individual servers that we then connect to with services. But we'll probably be wrapping these in services or just leaning on external services, so they don't have to have our own stuff. We have some hooks, like hooks are a feathers thing. They can get run every time a request happens, so you can have this like check for the spell, check if it's in the manager. This could be used every time, as a hook in a bunch of different services. In the spell runner service, make sure that the spell is already primed. In maybe other services around that, and probably some of this could be a little bit folded a little better, but we have like the get spell helper. These are just obviously kind of just little functions and stuff that help. In shared, we have this is code that's shared by the client and the server, right? So that's stuff like the cost calculation, which we'll need to add to, and we're probably going to make this a bit more. This is going to be moved into the OpenAI plugin and then loaded from, because we also are supporting Google Palm, so now we need to have. We're trying not to hard code all of our like OpenAI stuff. We'll move this out. But the idea is that the cost calculation, configurations, things like that are done here. Things like the agent class, which needs to be, it's shared because even though it only runs on the server, we use it for typing and stuff in the front end. Agent manager too. Then we have like data controls. These are the actual UI controls that show up in the front end. Like this input type here is a drop-down data control. And you can see the drop-down control. So these correspond to the inspector controls. And these are shared because even though, like a lot of this stuff, even though it's React heavy, we also need it sometimes to be accessed in the backend or by the runtime itself. So that's why a lot of this stuff, even if it's front end only, is also it's still feeding into the runtime. Some basic functions: process code, process Python. This should probably be called process JavaScript. We support JavaScript and Python. We support Python through what's it called? IDE. So it runs in the browser in a WASM runtime. It's slow, but most of the Python that people are doing is pretty basic, like change a string around, whatever. So it's pretty effective for that. So yeah, we do have a Python node if you want to write Python. We nodes. This is where like all the heavy lifting is. In the core shared folder nodes, these are the actual nodes. Like this echo node, that's probably here in utility echo. This is the node. You can see a node. Basically, all nodes have a builder. The builder gets called by the front end to kind of set it up and show the display. You can see how it has like a string input, a trigger data input, a trigger data output, and a string output. That corresponds here to the trigger, string, right, for this echo node. Then it also has a worker. The worker is run on the server. So the builder is run on the client to set the thing up, to build the node. The worker is run on the server to actually process the data. And every node has this. I go to, let's say, events, right? Event recall. And you can see there is a builder right here, the builder. And then you can see there's also the worker, right? And the builder sets it up, says like, here's the inputs, here's some input controls, that these are what will actually go into this side over here in the inspector. And then when you actually call the function, call the worker, and do all this stuff. Okay. Then we have plugins. Now we have two kinds of plugins abstractions. We have Magick plugins, which are in the plugins folder over here. And then we have these plugins, which are, they're actually Reet plugins. So we use Reet.js under the hood. Reet.js. It's here. It's a cool framework for visual programming. The Magick nodes are built on this framework, but it's heavily modified. And while they have their own plugins, we basically had to modify every single one of the plugins we use at some point. So we brought them in and made modified versions of the Reet plugins that we use. Some of them are completely different. Some of them are brand new and not really even in the Reet ecosystem. And some of them are modified versions of Reet plugins. So all of the plugins here, this is like the task plugin. This is actually how we move data around and manage these complex asynchronous chains. A lot of that is covered in here. Then we also have like the console plugin, which shows this console and reports it this over here and make sure that things report to this console, etc. The multi-copy plugin, the key code plugin, which lets you use fire off creating a node or something with a key command or whatever, etc. That's all covered in these. This is all about the nodes. So these are node plugins. And a lot of the functionality around the actual node graph, making a key command or a comment or a node appear when you whatever, that's all covered in these kinds of plugins. So this nodes and plugins really is like the core functionality of the runtime. Is a lot of that is handled here. The spell manager. So we call our graph spells. The spell manager is basically everything around caching and making sure that spells are loaded, cached, recached when they're changed, and run properly. It takes a bit of effort to process a spell and convert all of this like code into a final JSON thing that can then be run through the graph. It can take 10 seconds for a super large spell. And so we cache those in the spell manager so that, because once they're processed, they can run really fast. We can run them over and over. We can't be rebuilding and reprocessing the spell every single time we get a request. So that's the spell manager was added to kind of cache and manage that. And then we have individual spell runners, which run the spell, handle the lifecycle of the spell, but they're pulling from the spell manager if there is a cached version. So this is basically the actual spell getting run on the machine is in this kind of spell manager. That's then going in and pulling in nodes and sending, with the task plugin, which is in the plugins folder, and sending the data through the nodes, processing them, calling the worker functions of each node, passing the data to the next node, calling that worker function until it hits an output, and then gets sent out. We have just some code like the world stuff, 3D world and world manager, which I covered a little bit. Probably needs a little bit of refactor. A really important one is the config. So all of our environment variables are covered in this config. That way we can import them directly. We don't have to use process.env because a lot of our stuff is isomorphic. Sometimes we need import.meta.env. Sometimes we need process.env. Depends where we are. This abstracts a lot of that pain away by saying, well, if process.env exists, use it. If import meta.env exists, use it. But just make sure, even, the other thing we had was that if you wanted to like import the editor into a Next.js app, we had to have the variables be publicly prefixed with Next. And same thing with Vite, it'd have to be prefixed with Vite. So that handles a lot of this in this config. As you can see, we're saying, well, if it's Vite or Next or React, just don't worry, we got this. We can handle this. Cool. That's the core shared core packages pretty much. There's some other stuff that's pretty much you can dig through, and roughly everything around the runtime, the graphs, that's all in the shared core folder, and the shared core folder is at magickml/core is the package name. So lastly, we have the editor package. The editor package. So while the core covers everything in the runtime, and you could pretty much just use that to like make a Magick app that loaded a JSON spell and ran it, the editor covers a lot of the stuff in addition that you see here, which is like the this sidebar and the top bar and these windows, and I can change my layouts, and I can like pull open new windows. There's this new project window. All of this, let's see, I'll close that, is in the editor package, right? This is the editor. And the editor is all that React functionality. So while there's some stuff that we're sharing between different things in the core package that are React-oriented, pretty much everything React-oriented is in the editor. The reason it would be in the core is because we also have some plugins that use React functionality, and that needs to be imported from the core so that we're not creating circular dependencies. So nothing gets imported from the editor into our plugins. It all gets imported from core. And editor and plugins all import from core, but editor is where most of the front end stuff is. I'm sorry, that's a mouthful, but basically, if it's React, it's probably in the editor. It might be, it might be a little deeper in the shared core. Actually, looking at the code, we have components, and these are the much higher order components, like inputs, the menu bar, modals, etc. The tab bar, as well as any kind of panels, messages, etc. All of our context. So these are React context providers. If you've ever seen use context, the idea here is we can provide all the context we need for configuration, chat, the feathers services like WebSockets and stuff. The inspector has its own sort of handling. The inspector is this thing right here. We have the various layouts. So the layout provider handles switching different kinds of layouts. The Magick interface provides the interface which lets us like call run spell and get the current spell and stuff like that. Modals, obviously, PubSub. So PubSub is an extremely important part of what we do here. In order to get information from like one window to another, typically we'll create an event, then have somebody subscribe to that event, and then whoever's pushing data publish that event. So PubSub is how, this is things like save spell, or, hey, I just sent some data out of the playtest input. Hey, I just copied a multi-selection. I just pressed undo. And so anything that subscribes to the undo event will get called whenever something publishes the undo event, for example. So it's very important. Toasts are the little things that pop up in the corner. If I press Command S, you can see that's a toast. So that's provided here from the toast provider. That way we can make the toasts appear from any other module. And then workspaces, this is actually composing all of these providers together into this workspace. Let's see. Data, these are clearly the layouts for here. You can see we got these different layouts. So these are just JSON layouts. You can actually, I think, go to your app, like go here and go into your application and save the layout. I think that's how I usually do it. Local storage. I don't know, I'll figure that out. But typically it's stored in here somewhere in this persist. I can go and I can grab the layout or whatever. But we've like made some of these. I think one thing we'll be doing is exporting the layout. But you can see that this basically corresponds to these different layouts. Data controls. We have some data controls that are inside of the shared, but then we have these sort of higher order ones that are here. That's sort of weird, isn't it? Let's see. I wonder if these are duplicate. Wouldn't that be wild? It's possible. Yeah, I think so. Okay, so we might have to, I'll look at this. We might have duplicate code that we need to remove there for the data controls. I think those should only be in shared. Just some basic CSS stuff, some basic React hooks. We have a few different layouts. This basically corresponds to, like, this is the spell window layout, but we can have other layouts here. See how they don't have like a top, this menu bar at the top? That's part of this kind of Magick spell layout, Magick page layout. These are also React plugins, but they're client-only React plugins. So while most of the plugins that we had in the shared here are for both client and server, we also have some specific ones for the front end, and that's like commenting, selection, stuff that doesn't really matter to the runtime, but that helps you. Oh, and the React render plugin, obviously, to render it. That's critical to the front end editor. We have some screens. Right now, it's like the home screen, which is, if I go and make a new, you can see it's like kind of a home screen experience. We also have the a chat screen and a Magick window. I don't know which one this is. I believe this is one of these. If I like close out a spell, then I go here. See, this is kind of our home window. State, obviously, state is super important to all applications. We have a lot of state we have to maintain. We use a thing called Redux Toolkit. It uses Redux under the hood, but it does make it quite a bit simpler. As long as you read this is another thing you really need to read the API, read how it works. It will not be really clear. They have their own conventions for this. It's very opinionated, so you kind of have to read their tutorials and understand how it works to use it. We use Redux Toolkit to wrap Redux, manage the complexity, and then and kind of handle state for us. So, we have a lot of different state in here. In particular, in this API and spells. Like spells is a good one, right? Because you have a lot of code in here, but basically what it's managing is we need to do CRUD for spells, and we need to sync the state of the spell CRUD to our local state, so that if I open a spell here, simple chat, that I have this state here, and also this is reflecting what I pulled in from the database. So typically in React applications, asynchronous loading of things like, okay, I need to actually go get the state and then update the component is kind of a pain because it causes double rendering and problems. So Redux Toolkit manages a lot of the asynchronous and kind of HTTP side of pulling state. And a lot of that is covered here. You can see it's doing things like save spell. Well, that's creating a builder.mutation, right, of a spell. Here's the query function, and then and it's returning a base query that we can then call. Okay, well, you probably need to just read about Redux Toolkit to feel comfortable with this. I just don't think there's any other way. This is pretty opinionated, and they have their own way of doing things. we have some things, more of this, dynamic base query, great. Basically, the idea is that if we're on the cloud, we need to change the authorization and set the headers. So we've got it set up so we can dynamically do that. That's what all this stuff is doing here in state. There's some things like preferences and the store, and these are persisted. I think I can see tabs is doing a bunch of stuff. It builds the tabs, it creates slices, it stores them, and then that's actually persisted here in our persist root. You can see there's this kind of tabs. So Redux Toolkit is also persisting our state by storing it in the local storage for us automatically. The rest of it, windows are obviously very important. These windows tend to reflect these windows. We've got, the agents window, the document window, the editor window, quest window, event window. These are all these. The text editor is also a window. So a lot of the just the individual page kind of logic is in here. The utils are obviously just kind of various functional utilities. And that's pretty much it. Cool. So that's it for the packages. Sorry, that was a mouthful, but I think you get the idea. There's core, there's editor. The editor is kind of everything you see here. Core is like if you wanted to make a Magick app with no UI, but you wanted it to work and do everything it does, you could do that just with entirely depending on the core. The editor is published as a package. These will be published as Magick client core, server core, and core, which is the shared. And those will be on NPM. They already kind of are, but they're not the newest versions, and we don't have automatic deployment of them yet. The last part we have is plugins. All of the plugins follow the same convention. They use a plugin interface. I will show you a couple of plugins, and then you can kind of derive from there. So each plugin kind of has either a client server or a client server shared for things like nodes, secrets, environment variables, whatever. Those should be shared, right? Because the node needs to run in the runtime. It also needs to be displayed to the user in React. For OpenAI, you can see we have a thing called completion providers, which are completion providers are an abstraction for the text generation and other completion nodes. So a completion is basically any kind of these AI token prediction things that gives you back a response. We don't just want to hard code OpenAI in there. We also want Google, Cohere, AI21. So we provide the completions as a plugin system. And you can see we have a list of all the models you can get. These are the text completions. We also have embeddings for generating embeddings. We also have chat completions, which is GPT-4 and GPT 3.5. They each have a different handler, all that. Inside of the client of this OpenAI, you can see we have the controls. These are the actual controls that we need for the inspector. And these line up if I make a text generation node here. Generate text. You can see I have these inspector controls here for the model name, GPT 3.5 Turbo, whatever. I have temperature, tokens, top P, frequency penalty. And that lines up exactly here. Tokens, top P, frequency penalty. So all of this stuff here is dynamically provided based on the different kind of completion provider. And that way we can support lots of different models with lots of different settings. So the OpenAI plugin, the Google AI plugin, use these completion providers. We also have a relationship with Google. They provide us with Palm support, which is their model. And so that's, I could select Bison and use that instead. Currently it's disabled in our cloud build because we can't give people API keys for it, but we can share those with our team if you want to use Palm. The other, outside of the completion controls, you can see there's chat controls and there's text controls, and each one is going to have different ones. The embeddings don't need controls, so they don't even have any. And then most of the magic probably happens in the server for the OpenAI plugin. You can see we have these. On the other side, we have a completion handler. So the completion handler says, okay, great. So you set it to use ChatGPT 3.5 Turbo, which is a chat model. So when I call the output, I'm going to call the completion handler for that model, because each model needs to have its own logic to handle the completion, pull the result out, make sure error handling, error checking, all that. Each, we have a function for each different model in our or completion type in our system, and this is all provided by plugins outside of the actual core. And then you can see I've got like my make chat completion. It gets the inputs, it handles it, sends out some outputs, then saves the request, blah, blah, blah. And these are all basically the same. They all same thing. Gets some inputs, handles it, sends a request, etc. So basically, the long takeaway here is that for the OpenAI thing, it's providing it's just injecting some stuff for how we do our text generation and various nodes that are AI driven dynamically. For something like, let's say, Twitter, you can see we have a client and a server. We don't have any individual nodes for Twitter, but we do have connectors. And so the Twitter connector, if I go and I make like an input, the Twitter connector gets injected here as an input option. And if I make an output, IO output, it also gets injected here as an output option. So if I look at my Twitter connector, it has agent methods first. It also has an agent, right? It's because Twitter's it's an agent connector. Let me just look at the input types first. So you can see I have these input types. Right now we only handle feed, but it'd be great if we also handled DMs and mentions. And that's something we'll be working on. And so these input types basically say, here's the input type, here's the sockets it has. If you have a default output, then you should actually use this output type as the default. And that would be if my output here was default. It's going to be like, well, I don't know, you just told me to output, so I'm just going to use whatever my input was. And in this case, the input was the Twitter feed, so it would default there. And then I also have output types. And this is going to say, you have the Twitter feed output. It's got some sockets too, some output sockets here, like these ones. And then when you call this handler. And we have this handle response function. So this handle response function basically handles when you send something out to Twitter, this is the actual function that gets called. You can see it's calling handle message, like, retweet, whatever you need to do. The other key part of this is the get agent methods. Well, that function doesn't matter, but it produces two things that do matter. It produces a start and a stop function for the Twitter plugin. Because Twitter is an agent, we need API keys, login. We need to check that. Once we check it, we start a live agent, and the agent starts listening for changes. And then once we tear down our agent or restart it, we also need to kill that connector, so we don't accidentally get like multiple Twitter connectors running, because we're stacking them on top of each other. So every agent has a start and a stop function for its connector. So of plugin types, well, we kind of have the completion plugins, OpenAI, Google AI. We have agent connector plugins, Twitter, Loop, Discord, Blue Sky. And then we can also have some like node plugins. A good example is like, let's say search. So the search plugin has a node for search Google. You can actually search Google with the search node plugin. And so we have a shared Google search library, which basically just has the search Google node. And then that is imported into our client and server plugins. You can see all the client is doing is importing the nodes from the shared plugin search and injecting them here. So the search plugin, it just has like a Google search service and a Google node that it just got from this get nodes, which was called from this shared package, which you can see get nodes is just returning the search Google node. We could have many nodes. We might have many nodes in this search package. That'd be great. It'd be cool if it had search Bing, search archive, but we haven't gotten there. It just does Google now. So all of our nodes go in our shared library, so they're accessible to the client and server. The server pulls in those nodes, but also has some services. It has a Google search service that it does in the back end to handle the search. And then the client, all it does is import the node. It doesn't need any special functionality. So this would be the other kind of plugin, which is the like node plugin, right? It's adding functionality via nodes. It doesn't matter about agents. It doesn't care about connectors. It doesn't care about text completions. But it's adding nodes that you can then go in here, and hopefully I can go down to search and you can see the search Google. This is that node that was covered there, right? So it's actually directly adding functionality. So those are a few of the different types of plugins, right? There's one other type of plugin which would add windows and full functionality. So a good example of that would be like the avatar, right? So if I go to this avatar view, you can see here, well, this avatar is also a plugin. You gonna work? There you go. This character. So this avatar this whole window is the result of a plugin. That plugin is here. Plugins, avatar, client. This is a client-only plugin. There is no server functionality for this because it's really just like drag and drop your VRM to the client, talk to it. The rest of the functionality is covered elsewhere. It's just this kind of UI. We also have an Ethereum plugin, which is not enabled right now, but that has like the ability to compile Solidity, do all kinds of cool stuff with Ethereum, and that has its own windows. And the Ethereum plug actually has nodes, windows, agent connectors, so you can have a Ethereum with a private key. It's kind of the kitchen sink. It's one of the most complex plugins. It has everything in it. And if you want, give your agent some access, that's how you do it. Then we have something like the Esoterica plugin. This is where we do just some weird stuff for fun, like you can compute your natal chart if you want to make like a astrologer. We have some movie trivia nodes that we're working on. Yeah, that's just more hidden fun stuff. And I encourage you to go through and look at the rest. So that's kind of our plugin system. Plugins all follow an interface. They're not just, totally random. There is actually a client plugin interface, which I will try class client plugin. So there's a plugin base class, which has like nodes, input types, output types, secrets, completion providers, all the stuff that we kind of seen. The plugin class is extended to a client plugin, which has its own functionality, constructor, things it needs, as well as a server plugin, which has its own functionality and constructor and things. So the plugins tend to fall into either being client plugins or server plugins, all of them. If there are things in the shared plugin folder, they are probably imported by the client or server as well into their plugin abstractions. There's no shared plugin or shared plugin manager. It's more that the shared plugin library is providing the things that are used and consumed by the client and server. And mostly that means nodes and secrets. Obviously, for something like Twitter, let's say we go to our agents. If I want to enable Discord, I have an API key. The API key is a secret that is stored in the database and injected onto an agent at runtime. The goal here is we need to message to users that when you store your secrets, they are stored in our database. Absolutely, they have to be, and they are loaded onto an agent. However, they should never be exposed to any users. They should never be something that you could ask the agent for. The agent is not aware of their own secrets necessarily. They're injected into the connectors. Let's see. One other key thing, if I say in simple chat, if I make a variable, I'll make a text variable. I say this is a test. I save it. I can make this public, and it becomes a public variable. And that will also be injected. I bet you public variables. No. Well, public variables will be injected onto the agent when it runs. If I save this and then I go to my agent view, and I change this to simple chat, it needs to be public. You can see that, one other thing, I need to name this. I'll name this my text variable. I made it public, I named it, I go here, and I select simple chat. Now it's saying my text variable, and I can type in whatever I want. So this allows me to override variables onto agents and create 1,000 agents here that each have different variables, name, personality, list of people they know. It could be anything. It could be a lot of stuff. So, no. Eventually that would be cool, but but not yet. That's 5-dimensional. Let's build some really basic stuff first. Eventually that would be great, but agents are very expensive, and you could easily run up $1 million bill if you had a spell that created new agents. So we need to be very careful with that. Each agent will eventually run in its own pod. Right now they're running all on a single server, and we're just having a fat server. So we have to, as we move to Kubernetes and agents spinning up individually, you could imagine that if you're spinning up 1,000 pods in Kubernetes, it could get, you're gonna have to be very careful of that and have a good user experience to prevent people from bankrupting themselves, or bankrupting us when they don't want to pay their bill. So that's kind of how plugins work. I think I covered most of the things. I think one thing we should talk about is enabling and disabling a plugin. So we have a lot of plugins here. Some of them are enabled, some of them are disabled. Let's say we want to add the Google AI plugin to be worked on right now. It's not enabled right now. If I go to here and I try and create a text generate text, I have all these options for OpenAI models, but I don't have anything else. I want to add this Google model to my options. So I'm going to go, this is a little janky, and we're going to make this less janky. It's one of the big things it's on our to-do list. But we have client and server plugins. I'm going to add Google AI to that list. But let's say I only want to do this locally. I don't want to do that. I don't want to have to push this or change it. I'm going to make a .env.local. I'm going to copy these two lines, and I'm going to override them here. So now you can see this is overriding my environment variable settings. We use .env-flow. .env-flow prioritizes the .local variables over the .env. Also in .env-flow, yes, our .env is public and saved. It's not a private document. Do not put your API keys in here under any circumstances. You put your API keys in the .env.local. When I do that, I'm then going to run npm install. Let me get into my folder. npm install is going to run a plugin check and make sure that these are plugged in and linked. So this is part of it. I have to run npm install, and that will add these plugins specifically to the plugins.ts. That plugins.ts is placed into my agents folder here. You see there's a plugins.ts. There's also one in my client here, plugins.ts. And there's one in my server. Because the apps have to dynamically load the plugins before everything else. So this is our way of making sure that they get the dynamic imports done quick and correctly. Okay. The other part, once I've done that, if I'm making a new plugin, I need to make sure that it's referenced here in the tsconfig.base.json. And you can see we have like plugin Blue Sky client, plugin Blue Sky server. For some of them, like search, we have client, server, and shared. But this is how all the modules locate each other. I would love for this to be made dynamically, but currently it is not made dynamically. So as it is not, we have to manually add new plugins to the bottom here as we create them. And so even plugins that are disabled are still referenced here so that we can access them easily. So Basically, make sure that if you make a new plugin, you're also putting in the tsconfig.base.json, referencing it. Make sure you have it in here in your .env.local. A lot of times when I make a new plugin, I just find the one that's the most similar to what I want. Like I made the OpenAI plugin, I copied it, and I renamed it to Google AI, and then I went and I changed all the functionality by hand in each of these things. But that was a lot easier than creating a plugin from scratch. In the future, one of our tasks is that we will have an NX generator, which, sorry? I didn't hear that. Well, in the future, we're going to have an NX generator to generate plugins for us that will create kind of a stubbed out generic version. But right now, we're just copying and pasting plugins. That's how we're doing it. Okay, I think I covered everything in the architecture that I wanted to. Do you guys have any questions? Okay, sounds good. Was somebody else speaking? I'm not sure if two people jumped in there. All good? Okay, cool. I'm going to kill this video, and then I'll be around if you guys have any questions or anything like that. And yeah, that's it. I'll see you guys to stand up in an hour.